you have done special angles before. The other day we filled in the chart. I actually should have done that pause. Okay. So, for those watching the recording, we just listed the special angle table on the whiteboard. It's in the last set of notes. So, here, radius, the problem was, and primarily most mathematics was created because they had some real world problem they needed to solve, and they couldn't figure out. In this case, they had times when they needed to combine degrees of measurement with an angle to lengths of things. And how can you take 20 degrees times 3 feet?
Probably not.
You would get 60 degree feet. What's a degree foot?
A radian.
It makes no sense. It means nothing. So they wanted some way, they wanted to define an angle based on distance so that the angle had a distance component. So they, of course, took everybody's favorite shape, the circle. Whoa. Okay. We had our basic circle here that we're working with, and they said, okay, what's a distance on a circle that we know?
Distance, diameter, radius.
Yeah, but as far as along the, actually measuring on the edge, we know circumference of a circle, don't we?
Yeah.
So they said, all right, if I know circumference of a circle, what is circumference of a circle? What's the formula?
Is it 2 pi r?
It is 2 pi r. And so then they said, what do we know about the number of degrees it takes to go around a circle? 360 degrees. Okay. Well, and then they said, we want this to be true for any circle size. So as far as the radius goes, we're going to base this on what's called the unit circle. The unit circle is simply a circle with a radius of 1. So they said, for right now, we're going to make radius 1. If we make that a 1, then I really have 2 pi equals 360 degrees. We're going to define this to be a new angle since it's based on a radius of 1. We can call it radian.
Oh.
Okay? So we're going to say a 360 degree angle is the same thing as an angle we call 2 pi radians. Okay? So if that's the case, what is an angle of 1 pi radians?
108.
Yeah, you divide it by 2. And so we're going to say pi radians is the same thing as 180 degrees. That's the measurement you need to remember as far as converting back and forth between degrees and radians. That's the one we use all the time. If you look at the clock, notice what's at the 180 degrees mark? Pi. It's pi radians because 180 degrees is pi. So why is the top of the clock pi over 2?
Because
That is half a pi.
that's 90, isn't that 90?
90 degrees, which is half of 180. So therefore it's half of pi radians.
So we want to do it again now.
Now this is pi radians. This is 3.14 radians. If you want to change pi back to 3.14. So the clock is nothing more than a radian clock. Okay, can you tell the outside circle, the blue and green numbers on the clock? They're every how many degrees?
4. 2, I mean.
3?
From 0 to pi over 6 to pi over 3 to pi over 2. In other words, the numbers on the clock, if you were going around the clock, 1, 2, 3, 4, how far apart are they? They're 30 degrees apart. So pi over 6 is the same thing as 30 degrees. Now why is pi over 6 30 degrees?
Well, if you were to 6 times 30, would be 180 times 5.
Yeah. If pi radians is 180, what do you get to get 30 degrees? You have to divide by 6. So therefore it's pi over 6. So when we fill in this chart here, 180 divided by 6 is 30, so we got pi over 6 for 30 degrees. Okay, obviously 0 degrees is going to be how many radians? 0. Okay, this is one we're probably not too common. 180 divided by what gives you 45?
3.
4. Yes. 180 divided by 4 is 45, so therefore pi over 4 is the same thing as 45 degrees.
3, pi over 3.
And yes, pi over 3 would be 60 degrees.
Pi over 2.
I understood it.
And pi over 2 would be 90 degrees.
First thing I've understood this whole. This hasn't been very long.
So, when you're working with angles, if you're working in radians and the angle has a 6, a 4, a 3, or a 2 on the bottom, you know it's one of those special angles. So those are going to become very common for us. Okay, before we actually start doing the special angle values though, there's a few times when we do have to convert from degrees to radians. Most of the time we work a problem in degrees or we work a problem in radians. Occasionally you have to go back and forth between the two. So I need you to know how to convert back and forth between the two. If I gave you 120 degrees, how do I convert that into radians?
You divide it by something.
Okay, remember every time we've converted units, we multiplied by a fraction. Y'all have had lots of chemistry, physics by now, so you've been converting units and multiplying by a fraction. I want to get rid of degrees, so degrees have to go where? On the bottom. I want to change them to radians, so they have to go on the top. Okay, what's the relationship between degrees and radians that we're going to use? Pi radians is 180 degrees. So you're just multiplying by pi over 180. Okay, we always write our radians as reduced angles, as fraction angles. We don't turn them to decimals. So you just need to go, all right, I have 120 over 180. What's that reduce as a fraction? What will that reduce to? Yeah. Because the zeros will cancel, and 12 over 18 would divide by 6s, so it would be, so it's an angle of 2 pi over 3 radians is the same thing as 120 degrees.
On your journal.
I'm sure I had to. Okay, so to convert to radians, you have to multiply by pi over 180. So how do you suppose you do it when you want to go the other way, if I want to convert from radians to degrees? Yes, exactly. You're going to times by 180 over pi will take you the other way. So all you have to do is remember pi and 180 and then ask yourself, what do I do to need to make the units cancel? And you got it. So if I was to give you an angle of, say, well, maybe if it lets me write, 25 pi over 7, and I said convert that, how many degrees is that?
180.
You would multiply it by 180 over pi. And yes, your pi's will cancel. So then, this is just a number crunch. I think that's supposed to be 9. Sorry, I wasn't going to do that horrible a number. I was going 7 won't do 9. Okay, I didn't follow you. Yeah, that's degree, yeah. Sometimes they just use a little r. Yeah. Actually, don't use it that frequently.
I think 500, I did that.
And so 9 will go into 180 20 times, so you'd have 20 times 25. 20 times 25 would be 500 degrees. So an angle of 25 pi over 9 radians is 180, or excuse me, 500 degrees. So just multiply by pi over 180 or 180 over pi, and you can convert back and forth. That's all it takes. That's what the few book problems you have are. They're just converting back and forth. Okay. So now special angles, 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 and more special angles. Yes.
Calm down. I don't feel like you train yourself to do that.
I can't get across enough how important these are. If I was going to pick the number one most important thing you learn that will help you through all of trade, this is it.
Calm down, it's fine. This is very intense right now.
This is incredibly important. Can't tell you how much. So here we go. Basic. We're going to do this in both degrees and radians here. We'll start nice. We know you can look in the chart. If I say what's the sine of 60 degrees, you can simply go to the chart and get it. But what if I say what's the sine
of 150?
Okay, I'll do sine of 150. Okay, so if I want to know the sine of 150 degrees, 150 degrees is not in the chart. In fact, how do I even know that it has anything to do with special angles?
It doesn't.
Well, right now you probably won't necessarily know it. You'll soon know all the angles that are special. Okay, so you're going to need to go, where's 150 degrees? Which quadrant would 150 land in? It's going to land in second quadrant. Okay, now, remember when we draw our triangles, we always draw them down to the x-axis? So, you want to know what's that little angle between 150 and 180? That's 30. That's called your reference angle because it's the angle you reference in your table. So, the sine of 30 degrees, you would go, oh, sine of 30 is really just not radians. Okay. Okay, these are angles. These are not values. The answers to a trig function, sine of something, is a number. It's got to be a value. So it's a half.
That's the answer.
So, okay, now, the other thing you're going to have to do, which is this is where I could be rich. You have to watch your quadrant and check for positives and negatives. In other words, All-Star Trig class is with us every single problem, every single trig function. We're in the second quadrant. What's sine in the second quadrant?
Sine is positive, so it will be positive.
So, sine in the second quadrant is listed there, it's positive, so yes, it would be a positive 1/2. Everywhere in the third quadrant, it would be a negative 1/2. You're going to have to watch that like a bazillion times.
So it's the same thing, our reference angle is still 30, like.
Yes, your reference angle is still 30. Okay, suppose I said, ooh, let's get tricky. Suppose I said, let's find a secant of something. I want to do secant of 315. Okay, so where is 315? It is in the fourth quadrant. Okay, why do you know it's going to be 45? Exactly, Colin has picked it out. If you know you're doing special angles, and you got one that ends in a 5, there's only one choice. It's got to be a 45-degree angle. But technically, your reference angle would be from this line up. So you would be going from 315 to 360, which is 45 degrees. So your reference angle, yes, is 45 degrees. Now, how do I do secant? Secant's not in the chart.
It's
The reciprocal of which one? Cosine, yes. Is reciprocal of cosine. So I'm writing sine is the reciprocal. What's its reciprocal? Sine is cosecant. Tangent is cotangent. So if I want the secant of 315, I have to go get the cosine of 45. And thank you, yes. You would then have to turn your number upside down. So you would have 2 over square root of 2.
You need to rationalize this.
Okay, yes, you need to rationalize, and I need to show you the shortcut. When you rationalize this, you'll multiply by square root of 2, which will get you 2 square root of 2 over 2, which will cancel. You'll just be square root of 2. So if you have square root of 2 over 2, when you flip it, it's just square root of 2. So consequently, this square root of 3 over 3 on tangent, what are you going to get when you flip it? It's just square root of 3. Or, if you're down here at tangent of 60, which is square root of 3, when you flip it, you're going to get square root of 3 over 3.
So they're just the inverse.
Yeah, those two are just reciprocals of each other. So that'll save you a little time and trouble.
Well,
You don't have to do the algebra.
What about, like, the square root of 3 over 2?
Okay, the square root of 3 over 2, there's not anything. If you flip it over, but you might as well just learn to recognize it. You do need to rationalize. So you're going to get 2 square root of 3 over 3. So if you see that one, you know you're doing the square root of 3 over 2 version.
The answer is positive square root of 2.
Oh, yes. In this case, yes, I'm sorry. We didn't finish our problem. This one, you have to check quadrant. I should have done a different quadrant. Secant is positive in the fourth, so it would indeed still be a positive square root of 2. Let's do one with a little more pizzazz and excitement, because you seem like you remember this. Yeah. But I need my right triangle.
You might want to stop the thing around 15.
Oh, good point. Let's stop it.